you're going to be seeing my ugly face one more time. I've been on, I think, the past 4 weeks now, Matt.
I
You've
thought it was
been
the
with
last
me.
nine weeks.
Yeah, it
I've only
feels
done
that way.
like one stream this year, I feel like, but
With me,
I'm back again.
right?
With
With
you.
me. So
That's right.
I keep dragging you back. And of course, good
Wait,
friend of the show
hold
and
on.
friend of ours. Wait,
I
what?
I said this year, but I then realized it's September. I've done way
It
more
is
than one
September.
stream.
You do
I
have
thought
way
it was
more
like
than
March.
You go to the routingloop.net and just check it all out and stuff.
Okay.
We need to do that for reporting. And of course, we have Justin with us, Justin Davies, good friend of both of ours, way back in the Loft days when he was a lowly SA such as ourselves, but now turned PM of one of the fastest and hottest rising features and services that we have, VPC Lattice. That's what we're talking about today, right, fellas?
I hope so, because I forgot everything else.
Yeah, that's what I think that's what the title says, VPC Lattice. Yeah, so
did we update the title?
I think
right?
StreamYard does it for us automatically. And I see that Dominic is already on there saying hi. Hey, Dominic, good to see you,
Dominic?
as well as Ken, two good friends of the show. reInvent's coming around too, right? So we'll be hopefully seeing both of you there at reInvent, maybe join some of our sessions. I'm doing the Ask Me Anything this year. There's Matty Lou. Who's this guy? He looks familiar.
We're already working on slides for some sessions. I need to work on my session slides. And apparently, actually, this just in, so we're still figuring out timing for advanced VPC design, but there's a new name this year, and let us know if you like this one. Advanced VPC design and what's new in VPC. I don't know if I like that one.
How many times do you have to say VPC?
Powers that be. What's that?
How many times do you have to say VPC? I get it.
Well, that was the original joke. I was like, advanced VPC design and new capabilities of Amazon VPC. I was like, I need to get a third one in there. Anyway, that session's on the catalog, I think, now. So sign up. Yeah. It's always full. So
I took over your Wizards. Yeah, I took over your Wizards one. So now it's just Ask Me Anything. I wanted to do Networking Cowboys, but I guess, again, the powers that be are like, maybe Cowboys in different
you guys did
countries.
Networking Cowboys at reInvent last year, right?
No, we just made it Ask Me Anything. So,
but we weren't allowed to do Cowboys?
We're not allowed to do but we acted like Cowboys, so that was fun. But we'll be doing that again this year. I'm on that one. And then also I've got one on Ask Me Anything with MTLS. Basically, we've released, obviously, MTLS for application load balancing. And we've got other services like, I don't know, does VPC Lattice support MTLS, Justin?
Supports TLS pass-through.
There you go.
Which is customers can do their own MTLS over VPC Lattice.
And that is actually a very valid question that folks have been asking us as well, especially when you're talking about connected car companies and other folks that are selling things like, say, on mobile platforms and stores because they have to pass that certificate throughout their whole back end. So we'll be just discussing any questions like, how do I do this, or what features, whatever. So those are the two that I have. How about you, Justin? What are you doing this reInvent?
I think I have a chalk talk for application networking. Nice. I don't know if it's called for VPC Lattice or not, but I think we're going to cover a couple of new things we're working on, and VPC Lattice, obviously, and then kind of just open it up for any kind of application networking type stuff. I think I'm doing that with Eves. Eves.
I did that one last year, actually, with Satish, I think. It was fun.
So I think I'll be doing that this year.
You crashed it. Everyone paid more attention to you than us, so obviously they gave you the.
Well, you called me out. I was trying to just sit in the back and pay attention to my own thing. I was reading emails, and then some difficult question came my way by you.
Wow.
Justin was there to learn a few things, and he got dragged into the the talk. That's not the way it normally happens.
Like, oh no, now I got to listen.
To answer Dominic's question, Friday morning, actually, no. I heard this morning that there are no Friday sessions, apparently. I don't know if that's going to stand true. Scheduling powers that be might change things, but I think I'm going to be Thursday. So this will be the first year for, I think, the last 5 years that I'll be able to go to the reInvent party. So see you folks there.
That'd be cool. You also, Dominic, brought up another good point. Maybe we should come up with something. We'll put it on the routingloop.net, maybe. What some of the hosts or some of our favorite sessions are going to be. And then we'll, of course, get flack from the rest of the networking community because we didn't put all their stuff up there. Or we can just list everything networking.
I think it's really
cool. It would be cool.
There's going to be I saw some good architecture talks coming too. Like, I think Mark Brooker's doing 4 talks or something like that this year.
Wow.
So there's going to be some good talks across the board. Obviously, we're partial to networking ones, but there's going to be some security and architecture ones that blend some of the more traditional stuff with networking, of course. So I think there's some good stuff I'm looking forward to.
Yeah, there's actually word on the street, not confirmed any of this, of course, because it's all in motion. But we're going to have an under the hood session this year with some of our internal, we call them NX engineering team. So the folks that build the underlying constructs of VPC. So I'm actually looking forward to that one. Maybe I don't know if we can do this. Can we jump into the catalog at some point when it's all there, and maybe we'll just start picking the sessions that we want to talk about them and kind of walk through them. So maybe that's a cool
great idea
for the session. Yeah.
That's a great idea. If anybody else, of course, thinks that they would like to see something like that, please just let us know, and we'll definitely go ahead and do it. Yeah, I would definitely do it. I want to definitely see the under the hood, because I remember the last time Colm did the one about how they did all the shuffle sharding and setting up
another billion flows, I think.
Yeah, that was like an amazing session.
The Eric Brandwine reinvented new version. Yeah,
it was a great one. So cool. So let's kick it off.
I think the idea is you get $1 for every time Colm says shuffle sharding, but
yeah. I thought it was a shot, but I guess you can't say that anymore.
You take a shot. I was trying to be PG, but you know what I mean.
This is Twitch, these people, they can understand. They can take it. So Justin, why don't you give us a little bit of an introduction? I know you've been on here a few times, but for the folks that are just watching, and of course this is always recorded on the routingloop.net. You can go there for previous shows, but let everybody know a little bit of your history of, like, because we were just talking about back in the day when you were in SA and talking at our lofts, if you remember what the lofts were. So why don't you give everybody an idea of who you are, how long you've been around, and what we're talking about today.
Sure. Yeah. So I'm very traditional networking background, like probably a lot of the folks on here. Real networking, internet service provider, backbone, MPLS, BGP, things like that. Dealing with
tuning sonnet rings,
spanning tree issues, spinning up our first packet over sonnet ring and a local service provider out in Las Vegas. But when I came to Amazon, it was kind of when I was at Juniper working on some SDN type functionality and learned kind of what modern networking looks like, the fake networking stuff. And so I got interested in Amazon and came over here as a solutions architect, focusing mostly on networking stuff. But when you come in here and it's a totally different game, you got to learn why NAT happens so many times and why your EC2 instance has a different IP than the IP that you're talking to things, even though you didn't configure NAT. They called an elastic IP. Yeah. I remember actually, I was up in San Francisco and I saw Matt, and I remember picking his brain because he'd been here already going through this stuff and had a very similar kind of networking background as I did. And I was like, Matt, how many times are we going to do NAT on this? Like, I don't understand what an elastic IP address is. And so it was funny because now I feel like this is all stuff that's just second nature to me, because you're just surrounded in it and you're familiar with it. But it did take a lot of time to kind of just ramp up and shift focus. But over time, that became second nature, and was working on networking stuff and got really interested into kind of how do we make next generation networking possible. And that's when I got plugged into VPC Lattice and started working on that for the last couple of years. And so now I'm the product manager for VPC Lattice, and I mostly focus on kind of application layer networking things, proxies, and how to bridge security functionality into networking layers, things like that. But my heart is still obviously in the backbone stuff as well. So
the traditional networking layer 2 BPDU stuff.
Right. And it's funny, it's like we obviously have that too here, right? Like we've got giant networking teams that do such an amazing job in just, BGP ninjas, writing their own IP stack type information and things like that. And the funny thing is they've always called it like, oh, when you're talking about networking at AWS, it's the fake network and the real network. The fake network's VPC and all that kind of stuff. And then you got the real network, which is under the hood.
Yeah.
But I don't, Direct Connect kind of fits in both, right? It's like kind of like a little bit fake and it's kind of a little bit real. It's got both sides. It kind of bridges those gaps.
I would say it's very real up into the point where it hits a AWS port. then it gets into what you would be considering the fake realm, just because you still have the lease line problems, still have to deal with the partners. You got to figure out, you still have the old ad trans and stuff for some cases, depending on what kind of line you get. So yeah, anytime you touch a cable, I think that's fairly real.
That's Is there a cable involved?
I'm trying to remember the exact scenario, but I think it was when you did first join, Justin. We left our, I think it was a Market Street office, and we're walking to where the loft used to be, and that's like maybe 6 blocks or something. Now it's right in the same building, but it was like way down there walking down Market Street. And the whole time it was just question after question after question after question. Like, why didn't we do this? Or could we do that? Or why didn't we think about that? Or how does this work? And why did we do it this way? And I'm like, I don't know, man. Like, I'm not sure. But the funny thing is, at the time, like, you feel like you're just learning AWS and you're like, hey, like these things don't make a lot of sense. Then it gels. But I think what you've done is you've moved into the realm where you're like, hey, it makes sense, but I want to make it better. I want to build newer things. I want to build new constructs. And I think your career path, which I think is like so awesome, and it's an inspiration for other folks, where you're now in the product team and you're building all of the things and the ideas that you first had at that point in time. You're like, hey, what if we had some kind of application networking that provided this kind of interconnect? That's a product that you've helped build, right? I mean, it's just such a cool story.
Yeah, like I think when you come to Amazon, especially in an SA role, one of the first things you learn is a topic that comes up with every customer, which is kind of migration strategies, right? And when I've been here for a little over 8 years now, and so I used to have a lot of conversations around lift and shift, the idea of like, hey, I've got an on-prem environment, I've got all my stuff living here. How do I just move quickly to get in the cloud and start benefiting from this stuff? And the original kind of like concept was like, well, there's a strategy called lift and shift. You literally don't refactor anything. You kind of just take what you got, replicate it in the cloud, same amount of servers, same amount of everything, and you just run it. Then it was kind of like, okay, as quick as possible, now that you're in the cloud, well, let's do cloud native, right? And it was kind of this idea of like shifting focus, using load balancers, horizontal scaling, all these kind of things. And that was great too. But it's like, now it's funny is like, I never have a full-on lift and shift conversation anymore. They still exist, obviously, but it's like you don't really come across these too often. Most of the time, even if customer has a workload on-prem, they've already got part of their workload that's fully cloud native. It's containerized, it's microservices, all the things. But it's like one of those ones where it's like, okay, what do we do now? Okay, so we've gone through the transition of lift and shift. We've gone through the migration to cloud native and made things optimized. But in all reality, the things we built for the cloud native networking technologies were really kind of just like primitives that made sense in the old world that people could kind of like say, okay, that makes sense. I'll put a load balancer in front of this. I'll do all this kind of stuff. Subnets, VPCs, data center, like it's all the same kind of constructs. And now we're in a world, though, that we can actually take advantage of new things. Like if we were to rethink this and we were to think about like, I just want these 10 things to talk to each other. And I want them to be able to talk to each other on these protocols. And I want them to have these security policies. We're in a world now that like this kind of stuff is possible where I don't need to make the customer spin up every single part in the packet flow, right? Like I can assume some things and really kind of implement a best practice behind the scenes so that the customer doesn't have to. And so now that's the kind of transition we're in now. It's like moving customers from cloud native to whatever the heck that next thing is.
Right. And also, I think a lot of it has to do with, I remember when I first started, that was the big thing when I was a generalist, like, lift and shift and then modernize. But the problem with the lift and shift piece back then was it was still fairly expensive, right? You're basically doubling your infrastructure in 2 locations. You know that it's not working well. And certainly when you bring it to the cloud and what it has to offer, there's a lot of efficiencies that you're just completely missing out on. And then one of the next hurdles obviously was, well, if we're going to modernize, now we got to train up all of our engineers to learn some of these networking pieces or security pieces or whatever. And that's again where like you working on the service teams, working as a PM, starting to build products from that point of view, saying, okay, how do we make connectivity easier, right? How do we make, instead of always having to focus on security being this blaring red button, how do we just make it part of the way you build things or connect things together? Like, again, one of the recommendations I was giving to a financial institution about an audit they were going to go under using VPC Lattice. And I just told them, just, export all of your policies and show it to the auditor. That's your firewall, right? You built it already organically. There's no reason to I have to put this in here, I have to create this routing here between this and this, and to have that all fall on the shoulders of, either a traditional networking folk or developer.
Well, yeah, so that's a really good point is the auditor piece, right? Because if I look at just the segment where there's a ton of traction with this kind of stuff is financial sector. And there's just so many things that other customers don't have to deal with that they've got to deal with, right? And the hardest part is when you do have all these components, you got a lot of stuff to manage, right? You got a lot of VPCs, you've got network route tables, you've got the actual component itself, metrics and logs of each of those components. If you're dealing with multiple VPCs, that means you probably got VPC flow logs, you got a transit gateway in the middle, you got those route tables you got to look at. Is there any kind of network ACLs involved or security groups involved? Then you've got the other side of it, and then you've got the application side. All of these workloads either have a network load balancer or an application load balancer in front of it, almost all of them. Sure. If they've got a network load balancer, they've probably got an Nginx or something like that behind that NLB. And so all of these things are independent things that a compliance person or a regulator needs to go and look at and say okay, show me the logs, show me the policies, show me the permissions. Okay, now let's do a mapping of all the IP addresses and what it makes sense. If it wasn't added anywhere, how the heck do I find all that?
Yeah, right.
And it's torturous, right? And so one of the things we wanted to do is to say okay, we can squash all of this. If we built something that was network connectivity and the proxy, that in one device, right? And I say device in quotations because nothing in the cloud is like a device. It's just now I can print out one audit log, right? And it tells me exactly where did the traffic come from? Was it authenticated? Who was it? What service network did it go through? What service is it associated to? What target group did it go to? What instance did it go to? And all of that stuff is in one log. Of course, you can still look at flow logs and all that kind of stuff, but it just gives you this one place that an admin can turn on for all their services, right? That is so fundamentally different than the old way of doing things.
Correct. And also don't forget the meta aspect. Who's sharing it with me? Who am I sharing it with? Right.
Totally.
Between the different accounts. Realistically, back in traditional networking, who did you share this with? It's well, let's follow the cable and see who's plugged in, right? Or we'll do a Wireshark and then we'll go look up on some MAC table to find out what. And that was, unrealistic. You know what I mean? So nowadays, you could definitely do it. And then the last piece, again, tying in, I always like to pull this in, but CloudTrail is that one piece that also tells you who touched it last.
Totally. Yeah.
Who configured this last and why, when, where, all that stuff. So all that combined now is just giving so much more power and so many more tools and so much more intelligence into the way that we do things or the way we plan things, what we can do. So going to that auditor, you don't have to sit there and sweating bullets going, okay, where's this, furiously typing in some Linux box, hoping you're going to find that one rule that they're looking for.
Yeah. Well, I think about okay, let's say I've got a VPC and that VPC is connected to 10 other VPCs. Could be 100 other VPCs. VPC peering, transit gateway, doesn't really matter. If an auditor's saying, okay, what does this VPC have access to? Well, now you got to go, okay, well, it has access to that transit gateway. And the auditor's going to say, okay, what does the transit gateway have access to? Oh, well, it has access to all those other 199 VPCs. And okay, well, what's in those VPCs? Oh, well, let me go take a look. Okay, well, and how are you securing this? Okay, well, let me look at my firewall that's split up over there, but I've also got another firewall over there. And security groups, do I need to audit all those kind of things? There's ways to do it, and it's very scalable. It's just contrast that to, well, what does that VPC have access to? Well, it has access to that service network. What does that service network have access to? Well, it's one list API call, and it tells you exactly the port and protocol and service that is on the other side. So it's just a different kind of animal and different kind of world. And that's kind of, I think, where we're going in the modern networking sense, right? Is all these components should have names to them. And we should be able to determine what things are connected by their names instead of just arbitrary IP addresses and network segments and things like that.
I bring up identity-based
that fake networking gives you more observability than real networking. That sounds like what I'm hearing here.
It makes it's more layman, right? If you think about it, and by layman I mean that in a good way. Like if I print out and I put a Wireshark or EtherShark display on here, there's not many people who are going to understand immediately what's going on. But if I export a policy, again, a VPC Lattice policy, you can just read it almost as in plain English. This person has access to this resource under these conditions, right? And then you just give that away instead of me having to explain, well, no, this is actually where, just like you said, Justin, this is actually where after it did the NAT, the packet goes through and then it hits this particular thing and then goes, and you have to sit there and explain it. Because let's be honest, a lot of these folks who do these auditings and a lot of the folks that are making these decisions are not necessarily at the same, let's say, technological level as the folks that are actually performing the tasks.
Yeah.
So
think about the old networking day, right?
We're describing what these networks look like, and I can kind of imagine them in my mind's eye as we're walking through like what a transit gateway and VPCs look like versus like a service network. But I'm kind of feeling like we should be whiteboarding some of this stuff out. Should we just like do a quick kind of comparison between the two types of architectures and then talk about maybe some of the best practices around when you're building with things like VPC Lattice?
I already put it up there. Are you? And I see your name next to that little cursor. So
oh, that's my name. Yeah, I'm over here.
You
I'm gonna hide up here while Justin does some drawing.
All right, let me just go ahead and remove my here. Do you see my here there, Justin? Yeah, you're there. Okay. Take it away.
Let me see here. I'm not very proficient at Miro, so let me just.
I don't think either of us any of us are proficient in this tool. I mean, we love using this tool because it's like a shared whiteboard, but it takes a little getting used to.
Yeah, it's about as far as we go. Also, I have a slide that compares the two different pieces just for another presentation that I was doing. We can bring that up afterwards. I should rename it though now to real networking and fake networking. And I'm going to say that Justin said it was okay to call it these things.
That's I originally got that from
questions.
Yeah.
Yeah, let me figure out how to find Jamie's cursor here really quick.
Let me just. I'm going to put a.
Can we do iPads instead?
There you go.
Draw a target here. There we go. We're over here somewhere.
Did you find it?
For folks that have ever used this tool before, when you first log in and have a look at a whiteboard, it's like infinitely large, and you've got like a little dot over here that might be where some people are drawing. So
true.
There we go. And is our border like this maybe? Yeah, something like that.
Okay.
I thought we were supposed to have no borders. That was not political. That was only about borders in terms of networking conversation.
Networking and security borders.
Networking and
security real world. Fake borders. Virtual borders.
Fake borders. Yeah.
All right. So maybe I'll try.
There you go.
Is there a box there?
Yeah.
It's a very faint box though. Maybe crank up the
thickness.
The point size of your the thickness. It is labeled thickness.
Here, can I share my iPad screen? Is that
you can certainly share your iPad. Yeah, I'll remove this, and then Matt and I will use that. We'll call that the big
entertain the group while I get my iPad plugged in.
All right, here we go. I'm gonna present this slide between fake and real networking, and then you guys can tell me, and folks, you guys also on the chat there can also let me know if this makes sense or not for an upcoming thing that I have to do. So I'm going to stop share and then present.
Justin, I don't know what kind of box you just drew on the whiteboard, but it can't be erased. It's like you used a permanent marker.
You used a permanent marker.
There we go.
So, and this slide I was trying to highlight.
Never invited me to Miro.
I know, right? This man, I'm just going to let everyone know who's watching. This man can design some of the most complex, tools that make it so simple for folks to use, but yet a shareable whiteboard.
You know, once you have kids, you turn into a 1,000,000-year-old instantly. And
That's
so
brain
I
for
can barely
sure.
use my iPhone anymore.
that's definitely true. Definitely true. Yeah.
All
So
right.
this basic thing, this slide that I came up with for a different presentation on traditional and application networking, I broke it down into focuses. You know, there are different aspects. So the focus for traditional networking I put down is like connecting devices back and forth, right, and having all of that managed. As opposed to the application networking is all about connecting services and connecting applications. And then when you're looking at traffic management in the old ways that we used to do things, it's kind of based on IP, routing tables, routing protocols, different ports, right? Tuples, as we call it. I mean, we still have those concepts today, but that's how we basically managed our traffic: is what's the IP coming in and what's the IP coming out. And now with application networking, with a lot of things that we're doing, policy-based things that we have, like for VPC Lattice, we're managing it more on the application's behavior. What service does it need to talk to? When? What action is it trying to perform? Right? And how quickly is it getting it back? Same thing with the security controls. We were talking about security groups before, also talk about firewalls. These are the things that we put in the line or in line, and we still have them available to us. But now with the application networking side, we're starting to also look at how does the application look in a secure manner? How does it securely talk to the other services that they need to talk to, or other applications we need to talk to? What can we tweak in the app to also enhance that security instead of just relying on that firewall? I don't know how many times you guys ran into it in your careers, but it was like, we kind of screwed up on the app and this one port's open. Can you just put in a firewall rule to make sure they can't get to it? Now we're asking folks to do that actually in the code, build it in. And then for scaling, now I know this one could be a little controversial, but when you're doing your routes, you have routing protocols, and that's more for dynamic changes in the traditional networking sense. But a lot of stuff tends to be pretty static, adding new routers, adding new switches, right? Adding in new transit gateways and setting in all those static routes and those, and that takes time, could cause some outages, could not. Whereas when you're looking at the application networking side, you want this to be a little bit more dynamic. My containers scale out and automatically call through AWS load balancer controller to pop up a couple of NLBs to go to direct to pod without me doing anything or touching anything, just telling the app, this is what is needed and these are who you're talking to. And then the last is, of course, use cases. A lot of the traditional networking is very data centery, right? LANs, WANs, getting connected to the cloud, getting connected from one site to another site. But when you're looking at application networking, as you were mentioning earlier, Justin, we're now in a cloud world, right? Where a lot of the big players are using the cloud, so it tends to be a lot more cloud native. We're interacting with their applications through more APIs than we were ever before. We used to always be that really crappy looking web page and poking the right buttons to get what you want. And now you have apps calling apps to do different things. And then, of course, we've got a lot of microservices too, which comes with their own problems. All that micro segmentation that you can get with microservices. Each Lambda is having their IP addresses. Who are they talking to? What version is talking to what? So app networking is there kind of scooping up all of that. So how did I do? Do you guys think this slide's actually worth it, or did I miss the beat? What am I missing?
No, I think this is actually a great comparison. Tell me if I'm thinking about this the right way. Traditional networking feels like it was about domains and perimeters and walled gardens and like VLANs
OSPF
and
is going off in my
VRFs
head
and
now.
routing, right?
Yeah.
And so you basically would connect things into these big domains and then they could all talk to each other. It feels like what we're doing here with application networking is really specific connectivity, right? You're saying this, it's not, I don't know if it's intent-based networking, but there is definitely an intent behind it to say, hey, my intention is to connect this thing to that thing over there, and we're going to stitch that connectivity directly. Now, I think what we've been pretty successful in AWS in doing is sticking to the same domains and wall gardens and VPCs and transit gateway route tables and subnets and the things that we're familiar with. And maybe that, like with VPC Lattice, it's kind of like the newer evolution of networking is almost the way I'm thinking about it, right? It's a far more efficient way of connecting things. I don't know if I have the right mindset around this or if there's anything you guys want to add, but it's kind of my take on it.
Let's go to the master who's inventing everything application networking. Justin, your thoughts?
Yeah, no, I think it's pretty spot on. I always think of it as labeling. Behind the scenes, I don't want to be tricking everybody. Like, we're using regular IP technology. We're not doing anything crazy fancy. Of course, like there's the traditional cloud type stuff where when you send traffic to Lattice, it's a proxy. but it's not just one proxy, it's a lot of proxies. What
Correct.
AWS is really good at is making a distributed architecture look simple. It's not simple. The protocols and things like that, we try to keep as simple as possible because it's just at our scale, keep it simple, right? Like you have to be simple to be scalable and efficient and make it easy to troubleshoot. And that's part of the reason why we write a lot of our known networking stack is just like, we don't need half the other things that a traditional routing software needs. We need much smaller. And it just allows us to kind of own our own code, do our own upgrades, understand our security footprint better. And so a lot of those kind of things are just still happening. It's just greatly simplified and we do it at scale for you. And so
I think
the way that I think about it,
don't sell that short too, because scale is a big part of it. I mean, I always tell folks too when they're like, "Oh, we could do this in our data center." It's like we don't have a stack of partner, devices running our network, because if we did, at the scale that we operate, that data center may be larger than the data center our customers are in to be able to manage all of these things.
100%.
I'm actually feeling a reInvent sticker coming on. VPC Lattice, simplicity at scale.
Simplicity at scale. Look at that. I know a good person who can design them. He's really good at it. I gotta get the pointing right. So I got your whiteboard up there, Justin.
Yeah, I know how to use this one.
That's good. Why don't you walk us through some of the concepts that you were talking about in terms of maybe traditional versus simplistic and how Lattice fits in?
Sure. Yeah. So I think I could draw up some of the example that I just talked about with Transit Gateway versus Lattice.
Sure.
The other thing, depending on what folks want to see, there's kind of two other things I was thinking about is I'm happy to show kind of the packet flow and what I mean by distributed architecture and how Lattice isn't just one thing. Happy to show that.
Yeah.
And then also the really popular one, typically on these kind of talks, I would say I probably have this conversation at least 4 or 5 times a week, is migration strategies. We can talk about some of that kind of stuff of just like, I already have a thing. Maybe I did it lift and shift. Then I went cloud native. Now what's the next thing and how do I get there? And so there's some pretty popular architecture patterns we can talk about there too. So
I think that'd be a great idea. Go for it.
Okay. And then folks just guide us if that's if you want to see something more specific or anything like that. But the example we were talking about before is this one where I've got a VPC, I've got a client and a VPC, and I've got a bunch of other VPCs, and they have different services in them. And services, this could be an application, this could be, it doesn't have to be a microservice. It could be some big monolith listening on port 80. Maybe it's not even doing HTTPS. That's totally fine, right? We just call them services. That's why I'm going to call them services. Think of it like a DNS endpoint. And so in the traditional world, the new traditional, AKA virtual routers. I'm not drawing up the data center. So traditional world, you could connect these things via something like VPC peering, something like Transit Gateway. In this example, I've got a couple of them, so I'll probably do a Transit Gateway. Attach the VPC, attach all these ones. And if it is a web service, I also have a load balancer, right? This could be an ELB. This could be an ELB plus something that you manage, like an Nginx, something like that. But the idea is basically, I've got a bunch of places where I need to troubleshoot. I've got the first and foremost, probably, when this customer resolves service1.com, what are they resolving to? Are they using Route 53 resolver endpoints here or resolver? And is it something that you manage? Is it something that you're logging and auditing? Because let's say it says, go to command and control out the internet to some far out land, right? The first level of defense is kind of like, is this going to the right place? Right? When I do this kind of stuff. And this is where DNS firewall and stuff come into play of how does this actually work? In this case where I'm just relying on routing, I kind of don't have any say because I'm just yeah, go to wherever this thing told me to go. And my routing table says 0/0 is out this way. So you got things like DNS firewall, of those kind of things. Or you can do security groups as a network firewall, but there's no way you're going to put every single IP address on something like a security group. You never get that access.
People try.
You could try, and it's great if you could say, I only want to allow local IPs or private IPs or things like that. But it's just like, in all reality, that's just the first level of defense. It can't be relied upon because IPs change all the time, right? It's really hard to do that kind of stuff. So it's just a basic level of defense. But in this situation, you're looking at that information, you're looking at the route table, you're looking at the flow logs, then you're going to the route tables and you're looking at the route tables here. And you're doing the exact same thing on the other side. It doesn't tell you anything to do with the service. There's no label on it, right? I have no idea what I'm supposed to be looking at. I just know that these two IP addresses are trying to communicate with each other. Maybe I know the port that they're trying to communicate. But then when you call the developer, you say, what is that? And they're like, well, what time of day was that? My container rotates every 5 minutes, right? And so it's just like, not helpful, right? And so it's great that that information exists, but it, again, gives you almost too much options. So contrast that with same kind of concept, but you have, this idea of a service network. I draw this thing as a circle, okay? One big question I get all the time is like, so how many hops is this? If I've got the service network and then I have a service here, here, and here, is that 2 hops? Is that 3 hops? What is it? This is a made up thing. This doesn't exist. Okay. It's just a logical component so that you basically have an abstraction that you can collect things and configure things and organize things. It's a grouping mechanism. That's all it is. Okay. So it's not a router, it's not a data plane, nothing like that. We do have a data plane, and that shows itself when you do configure a service in VPC Lattice. Okay. And for service 1, it's basically a logical front end to the actual service 1, right? I'll draw it beside the load balancer. Okay. And that is a data plane entry. So you go to this data plane and then you get forwarded on. But what this allows is you can draw out exactly what you want to connect to. Nothing more, nothing less. And so you know that if you have access to this service network, you literally only have access to the things in the service network. And you can actually put a security group on your instance, forget about IP addresses, say, allow traffic to Lattice. And you go to Lattice and you say, allow traffic with things that have this security group referencing, right? You're probably familiar with that. But what this allows you to do is say, literally, no matter what DNS resolves, no matter what you're trying to do, you can only go to VPC Lattice. And then you can, even without configuring policy, no authentication, no nothing, you're only able to get access to these things. And so it's just a very kind of simple way of putting a label on the underlying networking. All these things still have IP addresses. They do exist. It's just standard networking in the same sense. It's just we're bundling it together and making these things very tightly coupled so that policy, security, and auditing and things like that make sense, and it's very simple. There's no way that that gets messed up, right? You tell me what you want in this once, and we will map that for you. Okay. And so it's just a big difference of just kind of creating those abstractions versus having the abstractions live in your own instances and your own load balancers and things like that.
So Alex is asking a common question here. Does a service network live in a VPC?
So this is a really good one. So this is part of kind of question number 2. And there's the IPv6 cat. So you've probably seen talks at reInvent, and if you haven't, there's some really good talks. Colm did the one that I'm thinking of, and he did it at reInvent one year. He did it at the back when Facebook used to do the at-scale events. I don't know if they still do those or not, but he talked about something we call hyperplane and just kind of how shuffle sharding works and how we get traffic to different data plane nodes and things like that. And it's used across Route 53. That was, I think, the original implementation, but then it's also used for some of our data planes. And so Transit Gateway works this way, NLB works this way, Private Link works this way, Lattice works this way. They all are individual and unique data planes, but the configuration is very similar. And what that kind of means is, here's a customer VPC, and you probably have instances in here where your clients live. Here's the same diagram I was doing before, where I've got a service here.
Maybe the whiteboard's broken for me, but is that a me problem or a Justin problem? You never
That's
know.
the
I
adjusting
mean,
problem, you know?
the problems are generally on my side. That's all I'm saying. But
Let's see here. Let me
Every time
reshare
you
it really
see
quick.
Matt go, he's checking sound and echo and
I'm
light.
checking my audio. My audio is out of
Or-
sync. It has been for years. I've been trying to get it dialed in, but I've never been
Or
able
you're
to.
just praying to the AV gods that everything's going to work.
Yeah, please, camera, don't die.
All right, let me see here. Let me reshare.
While you're doing that and you're thinking, Dominic had a quick question. Is VPC Lattice integrated with Amazon Detective?
With Amazon Detective, not at this time any specific integrations. But what, comment in there and tell me what specific thing are you looking for?
Yeah, what do you need, Dominic, for, you know, in terms of like a solution and like I need to be able to do X, Y, Z? Let us know. Well, happy to talk about that.
Because I have some ideas, things I'd like to do, but obviously
also, by the way, folks,
so.
if there's any PFRs, which we call feature requests, this is the PM right here. Ask them, say, I want X, Y, Z. I want it served with a scoop of ice cream and a crepe, like any of that stuff. Please put them in the comments. Believe it or not, the PMs really are looking forward to your feedback and what they can build more for you. I'm sorry, go ahead, Justin.
No, I think that would be super helpful. I mean, honestly, do let me know. I think we've got a lot of things I can't quite talk about on this talk that you're going to be learning about at reInvent, which we're really excited about. But you know, I think we're constantly looking for kind of where are folks needing help. You know, what things would be interesting, and I think in the security space, whether it be guard duty, whether it be detective, whether it also be even things like inspector or things that are running on hosts to prove, you know, is a host actually okay? Not only can they authenticate, but are they able to, should they be able to authenticate? You know, like, is this a healthy node? Things like that are super interesting to us. And it's all stuff that we're looking into because that's a growing field, right? It's just one more layer in the defense in depth strategy. I always prefer to talk about defense in depth more so than zero trust, because if you think about zero trust, I mean, Amazon's been doing zero trust type architectures since the very beginning. If you think about every single API request that you do, the concept of, you know, being able to do a SIGV4 request and having short-lived credentials and making sure that you're rotating those credentials and all of that kind of stuff end to end is exactly what zero trust is. And so it's just one of those ones where we don't usually typically highlight it like crazy because it's just what we do in our fabric. You know, it's like that's what we've been doing. But I do like to talk about defense in depth because it's a super important concept. And I think the bigger a customer gets, the more important it is because it's hard to keep track of all this kind of stuff. And so you need these layers as kind of mechanisms like Swiss cheese. You know, like if you get through one hole, you want the next thing to stop you. And then hopefully you have alerts and monitoring and logs that kind of signal to you, hey, something got through that first hole. And this is the first time we ever saw the next layer being hit. And then you could investigate it, improve your process and all that kind of stuff. So different topic, but defense in depth.
Follow up from Dominic, who had originally asked about Detective. Says, I know that Detective is built on top of guard duty to analyze suspicious traffic to provide complete scenarios. So I'm curious about VPC Lattice because I saw in the docs that Lattice is integrated with guard duty.
Yeah, and the way that like flow logs and things like that are, there's some basic functionality that you're going to get out of the box. And so that stuff will obviously be supported and work. It's just some of the higher level stuff that I'd love to do is not necessarily there. You know, like there's not necessarily like a certain filter or thing that Amazon Guard Duty is going to do within the Lattice audit logs. It would be more around the things like VPC flow logs and things like that. And keep in mind, flow logs totally work in Lattice. So like in this diagram I've got up on the top here, when traffic goes to Lattice, we do pick the packet up from the actual ENI and deliver it directly to our data plane. And there's no way that you can manipulate that or steal that or shift it over, even if you use more specific routing or anything like that. Like that is one of the mechanisms that's so powerful about Lattice. There is no infiltration, you know, you just can't get in there. We take it directly from the ENI. And so one of the things customers are always asking is like, well, what about my flow logs? I rely on that stuff. All that stuff's still there. You will see this traffic in your flow logs. We will also honor your network ACL configuration or your security group information. That's super crucial. And that was a decision point. We were like, should we do this? Should we not do this? And absolutely, we're like, yes, like this is a powerful tool. Don't take that away from customers. And so all that stuff can be looked at in guard duty, and it's accounted for and all that kind of stuff. Just the higher level stuff is not necessarily integrated today.
That's a good point.
So the okay, so yeah, on the architecture perspective, customer VPC, this could be you. You have a VPC with a bunch of instances in it. It's making an HTTP request. It's a client. The other side, same kind of diagram. You got a customer VPC with a service in it. Client server, typical TCP relationship. VPC Lattice has a VPC, just like every other networking service. We have a VPC, and we have a whole bunch of network optimized EC2 instances configured in that VPC. And it is running the VPC Lattice data plane software. So we have a whole bunch of really cool kind of modern optimized techniques, eBPF, forwarding, and things like that are basically doing a lot of this kind of high level packet forwarding. Our proxy software lives in here. And basically we have a network attachment into this VPC. And we have a network attachment into every other VPC where you're either a client of a VPC Lattice service network or a service of a VPC Lattice service network. And when this request makes that DNS request, it gets an IP address that's a link local IP, the 169.254.171.space. And when that happens, each and every single interface in the VPC is programmed to automatically tunnel that traffic directly to the VPC Lattice data plane. And behind the scenes, it's not going to one IP. So it's not just saying, go to this IP. It gets shuffle sharded across per flow to different data planes, right? And this provides scalability, provides redundancy and resiliency, and just kind of allows AWS to do the cloud-like things that we do. So it shards across all of these, where this traffic has a ton of cool information from our SDN, right? Like, what VPC did this come from? What service network should I be looking at? And it gets that traffic all aligned in there and pointed in the right direction. And so once it gets to the proxy, if it is an HTTPS connection, we will go and actually terminate the TLS connection and then basically look at what the customer's configured. Do you want me to route this based on the header, on a path, on a method of the HTTP request, all that kind of stuff? And from that, we'll be able to take those rules and actually forward it to the right destination. And it's the same on reverse, right? So how I talked about coming from link local and directly routing to your backend, that's exactly how it works. There's no way to interrupt this. It's going to go to what this service owner configured as the target.
Now, quick question for the nerd in me. Those endpoints that you have, the 169 endpoints, are those interface endpoints or are those hyperplane endpoints?
So good question. So folks are probably familiar with private link, where in private link, a long time ago, people used to care more about it being like a special kind of ENI. We used to call them hyperplane ENIs. Mm-hmm. And there was different scalability factors of like how many of these you could have in a VPC and stuff like that. A lot of that's gone away because we've just improved the scalability so much where we don't really have those conversations anymore. But behind the scenes, it is a little bit of a different endpoint that allows this kind of load balancing and all that kind of stuff. A private link endpoint, I'm going to draw it a little bit different because, sorry, let me see here. What it does is you actually put an endpoint in one of your subnets, right? You put a VPC endpoint in one of your subnets. And then that VPC endpoint goes to something. Today, it would go to an NLB. Now, VPC Lattice is a little bit different. Okay, so I'll draw the other one. So another one that customers are familiar with is a VPC endpoint type called a gateway. And so like DynamoDB and S3, those have gateway endpoints. And I draw them as like little lines on the edge of the VPC border because there's no VPC IP. There's no ENI. There's no like logical physical endpoint. Yeah, exactly. And so we just kind of do that stuff behind the scenes for you. VPC Lattice is more that model. I would actually draw the internet gateway kind of similar too, because IGW is kind of similar, right? You attach it. VGW kind of similar. It's like more like a gateway. VPC Lattice is kind of the same way, where you go and you take a service network and you associate the service network to a VPC. You don't put an endpoint. And so when you do that, it creates one of these kind of like gateway ENIs where a customer doesn't have to manage it or think about it or anything like that. The big difference between a VPC Lattice association and something like these gateway endpoints is that we allow you to put a security group on it. You can't put a security group on these. And so you can on this though. So it's a little bit different technology, but the appearance and the kind of way to think about it, the mental model would be just like these, but with the ability to have a security group on it. And that's powerful, right? Because now if I've got a Bastion box or like an SSH jump to box or something like that, I don't want this thing that's accessible from the public internet to be able to get to my private things in Lattice. And so this allows me to say, put a security group on my things that I want. It's almost like a tag, right? Put the security group and then reference all those security groups on my association. And that allows me to kind of pick and choose who do I want to have access to these things in a very, very taggable way, right? Like this is what I talk about with labels, right? Like not only do we give a label to the thing that's over here, the resource, the service, but we're also putting labels on the sources, the security groups. Right. So that is the way to think about security groups and application.
What would happen if I was on an instance, or I'm this little human figure inside the VPC, which is going to be an EC2 instance, right? What would happen if I'm on that instance and I'm using Wireshark and I'm having a look at what the destination of packets are, like just for each of these gateways, like IGW, S3, DynamoDB, Private Link, and then Lattice. Like, what's the difference between all those if I'm looking at packet forming?
So we talked about this one having an IP in a subnet. You know, you pick a subnet per AZ and you put an endpoint in it and you say, this is the one I want it to be in. And it'll go and grab an IP in that subnet. And so if this VPC's subnet is like a 192.168 or something like that, it'll be something like that, right? That's the IP that it gets. Behind the scenes, we use a link local address, 169.254.171. something. And these ones actually will show up with public IPs. Okay, don't let that scare you. It's not a public connection. We're just using those public IPs to get the routing done. So this will be, I don't know if this is the right IP range. Don't quote it, but let's say it's 54. something. That's a space Amazon owns. So 54. something. And the internet, let's say you're going to, you know, give me a public IP that's your favorite.
8.8.8.8.
Yeah, everyone knows 8.8.8.8.
The problem if we have an actual real public IP, people punch it into a browser and then it brings up like some random site and they're like, hey, why are you guys sending me to?
Yeah, just to solve that, by the way, I did link the public address ranges for folks who care about it. We have a JSON document that has them all listed, so just put that in the comments.
Good late night study material. Put you right to sleep. Memorize them all. It'll be tested.
Right. Don't joke. That used to be a thing.
Oh, you should laugh. Like the other day I was doing like some actual subnet math and I was like, I have not done this in probably 6 years.
Yeah, I just bring up an app now.
There's a calculator. Yeah. I'm like, okay, base 2. What is it? Okay. So IGW, you're going to some public IP. S3 DynamoDB, you're going to some public IP. And Lattice, you're going to this. And a private link endpoint, you're going to this. And so if you ran Wireshark on your EC2 instance and you made a DNS request for whatever, one of these things, your Wireshark's going to show you a source IP of your own IP, right? Whatever your IP is of the EC2 instance ENI. If you remember my conversation, my questions to Matt, my 20 questions when I first met him, my 800 questions, it will be the IP of your ENI, the internal IP. If you've got an elastic IP on there or anything like that, you're not going to see the public IP. You're going to see whatever your ENI is. But so you'll see that. For the destination IP, you're going to see one of these. And so if it's a Lattice connection, you're going to see the actual IP of the Lattice link local range. If it's a private link, you'll see the actual endpoint IP. If it's DynamoDB or something like that, over a gateway. You're going to see a public IP. Again, don't let that scare you. It's not going over the public IP. You're actually being routed, and you'll get those routing entries as a prefix list over to these endpoints. Okay. And so you'll see exactly that, and you plus port and all that kind of stuff and the request details. But you'll see those IPs. I do want to make a comment, because we get this question a lot of the time too, is, well, that doesn't seem very scalable. Does that mean I can only have 256 or 512 or whatever the prefix is services in a service network? The answer is no. We don't actually use the IP to do routing. So this is just to get the traffic over to Lattice. And it's a way for us to secure this traffic. It has nothing to do with the service. There's not a one-to-one mapping or anything like that. We use the client, the SNI message in a client hello, if it's a TLS connection, or the host header of HTTP connection. So we're routing based on application layer things once it gets to us. We're just using this to get the traffic to Lattice.
Hold on a second. So what you're telling me is the IP address range in the first VPC with the little person in it, we'll call that Matt, and the IP address range in the adjacent VPC could be the same then.
Yeah, exactly. Because this is completely abstracted. Like the whole point was, I don't care if this is a V6 address. I don't care if this is a V4 address. I don't care if they're overlapping. I don't care about any of that, because the idea is that I want my client, I want it to be separated from the destination. I want these things to be disjointed on purpose so that I can simplify IP management, get rid of IP caring, improve my security posture, so have centralized policy enforcement and routing, and just simplify my configuration in general. And so you're always talking to Lattice. Lattice does its thing, and then Lattice always talks to your destination. And so that IP address is completely obfuscated. Now, first question you're going to get is like, hey, what if I want to care about that IP address? You're still going to get the information in the back end. So not only are we going to log all of that great information, but you're still going to get it. And so the actual server, like if they were to look at their HTTPD logs, they're going to see a whole bunch of really cool information, like what was the original IP address? What source VPC did this come from? What service network did it come from? What service and target group did it come from? And so this is cool, because think about how hard it is when your developer calls you and says like, I'm having a problem. And you're like, with what? They're like, I don't know, traffic's not coming. But like now you don't have to tell them, go look up this CloudWatch log entry. No. Can you do a show HTTPD and just tell me what you see there? And they'll tell you exactly where it is. And then you have that full packet path without turning on distributed tracing or anything. You get this for free without doing anything.
So now knowing this, and we had earlier in our conversation, you were talking about application networking making things easier for the user. I can tell you one of the more common things for our EKS friends is they always get their bristles up, if you will, of having to do an upgrade every 6 months because we force them to patch every 6 months. Can you kind of draw out how Lattice can actually make that into a simple process as opposed to what it is today or what it is without Lattice?
Sure. So I want to be clear that I love our EKS family, but one thing that is just a pain in the butt, and this has nothing to do with EKS, this is just Kubernetes in general, is just upgrades can be torturous. They can be painful. Usually it is kind of like a shut it off, let's restart it. And it's just not very like a new mechanism, right? Especially if you're dealing with big clusters with a whole bunch of things in it. And so we wanted to specifically fix this with Lattice. In the old model with regular like ingress routing, you'd put a load balancer here, you'd put a load balancer here. And this migration just got really kind of hard, and it was very all or nothing. And so with Lattice, you're not tied to VPCs. Okay. So you can create a service, and let's call this service 1. And you can specify target groups of this service that are in this cluster, right? Maybe this is a couple different services. What you can do is when you're getting ready to migrate, your client's over here, you know, the stick figure guy's over here.
We'll call that Matt.
This is where Matt is. What you can do is you can spin up a new target group, go and configure this, and you can specify that you want the weighted routing to be 0%. And so you go and spin up these new services. This is S1, S1, this is S1, same thing. You go and configure these target groups. I'll put a different color in there just for now. And now the client's still getting their same traffic profile. Everything's working just fine. But now what you can do is say, I want 10% of traffic to go to this one. Client doesn't have to do anything different. You don't need to change any routing rules, any TGW rules. The IPs don't even need to change, nothing. Right? This is also why it's a great mechanism for IPv6 migrations. And now you can get the traffic up and running on the new cluster, get everything up and running, make sure it's okay, make sure that there's no weird errors on that 10%. And then you can go and shift to 100% and go ahead and delete the old cluster altogether. So it's probably one of the best migration kind of tools that we have in our toolbox right now.
And if you need to preserve the IP, just as we were saying before, if you're building out a whole new VPC, because VPCs, just like anything else, can be fairly immutable, you can have the same IP address in both of those target groups, and everything will work just fine.
Yeah, and if you go on to the Kubernetes open source controller that we made for Lattice, it's called the AWS Gateway API Controller. There's actually a detailed user guide to show you how to do exactly this blue-green type of deployment, how to use native Kubernetes APIs to actually go and configure Lattice to do this. And so that's another thing that's kind of useful for folks. I'm not sure how many Kubernetes users there are. Is Kubernetes is a first-class citizen for Lattice. You don't even really need to touch Lattice APIs. You don't need to learn a new service. We are using native Kubernetes APIs within Kubernetes to actually go and configure Lattice for you. And that's what the controller is for. And so once you install that controller, you configure some gateway objects with your native Kubernetes services and
if you're familiar with the AWS load balancer controller for ingress controllers and for direct-to-pod controller load balancers for our ELD products, this is along those same veins.
Right.
And I put the link in below, or
perfect.
I'm so used to saying link in below. Smash that subscribe and like. I put the link in the comments.
So wait, one piece I missed before. Just back on the previous diagram. What does that routing look like though? And so we've got these 169 addresses, and I think this is coming from your comment, Jamie, that you can reuse the same IPs across each application, or if you're doing a blue-green deployment or something like that. Like in this case, just walk through the routing for each of these different mechanisms, and then what the routing looks like for Lattice, and how do we actually define what an application is, and how do we know what we're reaching or what we're connecting to, right?
Sure. Yeah. So on like kind of like a packet walkthrough almost.
Yeah, I love packet walks. Okay. Let's do that.
Who doesn't, right?
Okay. Yeah. So first and foremost, it all starts with just kind of the VPC. Like maybe what I'll do is kind of start this over so it's a nicer diagram. Say I'm trying to get to I've got an EC2 instance here in an auto scaling group. And let's say it's a 443, it's a web app, it's a front end or something like that. Each of these have ENIs, and maybe this is like, the whole subnet is 10.1.1.0/24. And so let's say this is .2, .3, .4, just for example, right? That's the IP of these. It's just nothing fancy. It's just an EC2 instance auto scaling group. It could be Kubernetes. It could be whatever, right? But that's just kind of how it is. They're in a subnet. They're in a route table, all that kind of stuff. On the flip side, I have, let's just say I have another EC2 instance. It could be an auto scaling group. It could be a Lambda with a private ENI. It could be whatever. Just think of it as I've got an ENI here. And Matt, the client, is right there. And this could be, it could be a different IP. It could be the same IP. For this sake, do you want me to do the same IP just to kind of show it? Or do you want me to do what would be helpful?
I mean, you could do the same IP.
Yeah, 10.1.1.0/24. I'll do.
I think I feel like this is a common problem that we see folks have, right? They go out and spin up a bunch of VPCs and they use the 10.1 space, and now they're like, wait, hold on, how am I going to chat between these applications? I'm kind of
or they acquired a new line of business or a new company, and they also have an AWS account, and we need to connect. Yeah,
that's the big one, or the one that was just like, well, I never thought I would need to because we never had dependency before, but now we do. Right. So there's a million reasons, and they just basically like every customer bumps into them. So same IP in this case, again, doesn't have to be, you know. But in this situation, this is, you know, let's say this is .2 as well. So in this situation, the first thing the customer is going to do is the DNS request. The client's going to basically just say, hey, where is service1.com? Well, service1.com needs to be created first. So I think we need to create the service first. And so if this auto-scaling group is there, the first thing you're going to do is you're going to go to VPC Lattice. This customer here is going to go to VPC Lattice API, and they're going to say, or console or whatever, and they're going to say, I want to create a new service, and I'm going to call it service1.com. So service1.com becomes a service, Lattice service. I'm just going to put LS, and that's service1.com. And it's going to ask you a few things. You're going to have to configure, very similar to a load balancer, listeners, rules, and target groups. Okay, and these can be pretty simple. Your target group is going to be basically the auto-scaling group, if this was an auto-scaling group. Okay, and so you're going to say, okay, I'm going to have a target group, and I'm going to attach this ASG. And that makes it really easy because now your target group just has one mapping. It's just like, cool. If you wanted to do individual IPs, individual instances, that's all possible. It's just, this makes it simpler. So it's an auto-scaling group. And you're going to say, okay, what do I want to do with it? Well, I want to just send all traffic to it. So I'm just going to have a default rule. Again, can be way more complex than that, but let's just start with that. A default rule of forward. And so I'm going to set up a listener. I'm going to say, okay, listen on HTTPS port 443. And I'm going to have a default rule. I'm just going to put DR, default rule. And I'm going to go to target group 1. Target group 1, we already defined, is this auto-scaling group. Okay. And so now you've just told VPC Lattice, you've modeled this thing, right? Again, it's just a made up thing, but you've modeled it and you've given it a name, a label. This is service1.com. Okay. So maybe I'll do s1.com equals that. And target group equals ASG123. Okay. That's kind of the full flow. Now this thing exists. It's a thing. It's got a label. At that point, there's another thing you've got to set up, and I'm just going to go over the kind of setup really quick just so that you understand the full components that are there. The next thing you got to do is spin up a service network. This is the made up thing. That's just the grouping mechanism. Okay, so you can say SN123, and I'm going to put service 1 in there. Okay, well, since I already have service 1, I'm just going to draw that line directly to it. Okay. So now I've got kind of this network built up. I've got the service. I set up the service network where I'm basically going to group these things. If it's just one, it might seem a little weird, like I don't need it, but this is just kind of how VPC Lattice works. You set up the thing because we're assuming you're going to have a whole bunch of them. So then the next thing is I need to set it up so that the client actually has access to it. And that is what we call VPC association. So we're going to associate that to the service, the source VPC where the client is. When I do that action, the association, behind the scenes, those little gateway ENIs are set up for you. You don't see anything, but it goes and installs all the link local information on every single ENI in the VPC. So now these ENIs have a route and have that tunnel created so that it can get traffic to Lattice. Okay.
Without having to actually provision a route in the route table of the VPC. We're not touching any routing. Right. We're taking care of that under the hood or as part of the service. Okay.
Exactly. Yep. Exactly. You don't do anything. It just shows up there and it's working. Okay. At this point, if you did not specify a security group, everything in this VPC technically has access to look up a DNS request and go and find this. Okay. Now,
just one thing I want to call out. So the name s1.com whenever anything in the VPC goes ahead and tries to make a call, it gets grabbed and sent right to Lattice, right?
Right. Yeah, as soon as it makes the DNS request, like a standard DNS request to Route 53, whatever Route 53 is configured with, if it's a private hosted zone, a public hosted zone, whatever resolves first, it's going to resolve. If you have some other thing, like let's say s1.com is a custom domain name, okay, and it's configured and it's pointed to something totally different. For example, let's just say it goes over TGW today, and you have a VPC here with an ALB. And ALB is configured as 10.2. Sorry, I'm going to use a different IP just to make it easier to explain. Let's say 172.1. If this client went and looked up s1.com and whatever DNS resolved for this VPC said go to 172.1, even though Lattice was configured this way, it's going to honor the DNS. And so it's going to say, okay, cool, I want to go to 172.1. And 172.1, if the route table said for 172.1, go to TGW, it will, right? And so this is how migrations work, because we're not going to interrupt that. That's totally fine.
Okay, so just to be clear, the traditional path, DNS request, a record response for s1.com is a 172.1. Packet goes into the subnet inside the VPC. That route table says, hey, you're a local 10.1. If you want to go to 172.1, I've actually got a route via the TGW. TGW then says, oh, well, you want to talk to 172.1? Go via that VPC. It gets inside that VPC. Traditional routing sends it to the application itself, or the ALB.
100%.
Okay.
100%.
So now let's throw in Lattice into the mix. How does it change? How are we mixing it up here?
Okay. So something, I was just drawing s1.com before. Let's say this is a custom domain name. You said, I want to call this the custom domain name. Cool. When you create a Lattice service, we always, similar to ALB, create another DNS name for you. Okay. So it'll be like Lattice s1.com. This is made up, right? Just it's a name that we generated.
Don't punch that into your browser. We won't
please don't.
Well, maybe
it doesn't
not
go
anywhere. It might.
If it does, it's not us.
So at this point, you've got these two DNS names. They're publicly resolvable. It's just they mean nothing to this person that doesn't resolve to that IP. It's going to resolve to some link local IP, but you won't be able to get access to it right away necessarily. If this client were to actually resolve,
if they're public, and like with traditional Route 53, if Jamie over in Buffalo, New York said, I want to look up this DNS CNAME, will he see the 169.254 address as an A record response?
He will. Yep.
Okay. But it doesn't mean anything.
It's useless. Yeah, it's totally useless.
There's no routing to that. Yeah. Okay.
Yeah, it's totally useless. And same with the ALB, right? The same kind of thing there. It's all the same. So at this point, if this client were to look up this alias, the one that we generated, it will resolve to that 169. And since they're associated to this service network, it will route. And we'll go over that packet path in just a second, but I wanted to close on the migration one. If they looked up the s1.com, which is currently aliased to the ALB one, it would say s1.com, alias or CNAME record to this IP resolves to the 172, and then it would follow the regular routing rules to get there. All you need to do is change s1.com alias to Lattice. You just update this alias, whether it's public zone, private zone, doesn't matter. And when you do that, it will shift the traffic so that instead of it replying with this 172 IP, it would respond with the link local that this one resolves to. And now that's when the traffic will say, okay, don't send it this way anymore. I don't have to delete any of this. It's just now DNS is going to say, okay, cool. What IP is it? Well, it's 169.254.1.1, something Lattice is managing behind the scenes. Then the client is going to formulate the packet and basically say, okay, my local route inside my instance tells me that the default route goes out this ENI. Okay. The ENI, you can think of it as like your ETH0 interface a lot of the time, but it could be a different ETH, right? But it's basically your network interface going into the VPC. As it sends the packet out and goes to the interface, before it even touches the VPC route table, it's identified as a VPC Lattice packet because we have a routing rule installed that's very specific in that ENI that sends traffic directly to Lattice for this range, for that 169 range. When that happens, it gets tunneled directly to the data plane we talked about before. At that point, the Lattice data plane, it basically sees a packet show up on one of its nodes that's probably encrypted because it's an HTTPS request. But that first packet is going to be a TCP connection that is a TLS client handshake, right? Setting up that first thing is, I want to set up a TCP connection and a TLS handshake. And that TLS client hello is going to include what's called the SNI field of the client handshake. The SNI field is typically going to be the host name, s1.com. Server name identification. That's what that field is, okay? And this is just part of the client hello. And when we get that, and we combine it with all the other source information, the source VPC, the instance it came from, and all that kind of stuff, we know exactly what to do with this packet and what service and what client it's associated with. And so now the proxy picks it up, and it's not just looking at, like a regular proxy is just going to look at, like, where do you want me to send this? Ours is looking at source information, where it came from, the client hello, all of that information. And then it's saying, okay, what do you want me to do with this? If it's configured as an HTTPS connection, at this point, we're kind of here. It's going to say, okay, cool. It's a TLS connection on 443. I'm going to go ahead and complete that TLS handshake. If it is a custom domain name, like we're talking about here, you would have, or you're going to need to, import that custom certificate that maps to that domain name as well. Could be a wildcard cert, it could be a SAN cert, doesn't matter, but it needs to match, right? Otherwise, the TLS handshake is going to fail. But once it does that, we're able to decrypt the packet so that we can go deeper. Okay, so now we've decrypted the packet. This is typical load balancing stuff. Same thing that this one was doing before. And then we can go say, cool, I've got it decrypted. What rules did you configure? Oh, well, the customer didn't really configure any rules. It's just the default rule. And so it's going to say, cool, I don't know, that's easy for me. Default forward all of this stuff to target group 1, which is autoscaler group 1. And it basically goes and finds that VPC, swaps the IP headers so that it's now coming from 169. It's not coming from this IP. And it's got a new destination IP, which is the actual destination that we're load balancing to. So it could be 2, 3, 4, depending on the load balancing algorithm that's there. This is basically where the natting happens, okay? When we do this, we also attach a new header on the connection. And that's where all that rich information is. It's basically an ex-Amazon header. Only we're able to add this header. If you tried to add it over here, we would erase it from you. So as long as if you have a security group that says it only allow traffic from VPC Lattice, that is a good way to say, okay, cool. I know this traffic came from VPC Lattice, and it includes this ex-Amazon header. And now I know that all this information actually came from Lattice. And so it's a very strong way of kind of saying, okay, what is all this traffic and where did it come from?
So just to kind of put just an extra layer on top of this, the 172.1, that was our old environment, or say that is our environment through the TGW, and we're now migrating to Lattice. So from what I'm seeing here, what you can tell me is that I'm using Route 53. For the s1.com domain, I could probably do weighted routing between the old 172.1 as well as the new FQDN that I get from Lattice, so that I can shape my traffic and say, okay, I want to try out Lattice and not jump immediately from one to the other and send some of my traffic one way and some of my traffic the other way. Does that work?
Yeah, so I probably should have drew it this way in the first place.
I think we didn't draw it like this just in the fact that it wouldn't work, because we were trying to do a 10.1 and a 10.1, right?
Correct.
Right.
And so now you've got overlapping IPs.
Yeah, if these were different IPs, exactly what you were talking about works. Like the typical migration scenario really is, I don't want to make my developer or my service owner do anything, right? Like they shouldn't need to be burdened by all this. So you can migrate them on their behalf, and they can keep their ALB, they can keep it all day and running. It's just you're switching it over here and the clients start migrating over. The client still sees all the same connections. And if you're using private hosted zones, you can do it per VPC, right? That's the beauty of it, right? It's like you can migrate this over. They can keep this up if they're still serving traffic from it. And then when they're ready, they can turn this down. It doesn't have to be an all or nothing thing. These can live in perpetuity. These can live forever.
So TechFueled has a question about the 169 address. Does this sound right that you would see a 169 in the route table?
You'll still see it. We put that in there on purpose just because we don't want to scare customers. We're trying to be as transparent as possible so the customers know exactly how their traffic is handled. And that's why, like, we come up with some really cool abstractions and really cool things, but like we're all about making things that are like still built on normal primitives.
So is it fair to say that really under the hood, and I think that's what we were kind of alluding to, you don't really need that route there? It's like we're taking care of that as part of our, I mean, you can say it's even part of Nitro. So the way Nitro operates, and there's a mechanism there that allows that routing. But in this case, we're like, so folks aren't confused and say, well, how does that even get there in a traditional sense? There is going to be a route there in the route table.
Yep.
Okay.
That's exactly right. It's like, it's exactly right, because it's just like if a customer that wasn't familiar with Lattice or something like that was looking around and using route tables as their way of like, what's allowed, what's not allowed, it could be confusing if this like magic little wormhole just allowed traffic out with no visibility. And so we did a lot of work and a lot of whiteboarding sessions, a lot of discussions with various, principal architects and security AppSec folks, different customers, internal, and just we're like, look, we want to make this super clear. No matter what tool or mechanism they're using to troubleshoot this stuff, we want it to be obvious. And that's why you see that, and we're not going to take that away.
That makes sense. So we have 5 minutes left. And traditionally what we do is we'll always say, definitely go to theroutingloop.net. This is where this episode will be on. I'll put it on after we're all done, all of our previous episodes and stuff. And this is also where you can give us how well we did and what else you're looking for. But also I'd like to, say to our guest, and to you, Matt, seeing as how you've only been on a few times, like, what are your final thoughts? Like, what is the one thing from today that you want all of our listeners and the folks that will be watching the video to take away?
So I'll go first, and then I'm really interested to hear what Justin says here, because I know, Justin, you're living and breathing this stuff. From my perspective, and I have a bit of an outsider view on VPC Lattice, this seems like magic. This seems amazing. Like it seems like there's so much functionality there, and I have this kind of gravity towards traditional routing and TGW, and like I'm even a little averse to Cloud WAN when it comes to it automagically doing things for me. I'm like, well, I just want to do have a look at the route table, but this seems amazing. And so I think there's a lot of stuff there that the customers should really start digging into, and this seems like the way of the future from a connectivity standpoint.
Yeah, I mean, I think I would echo a lot of that. I think that there is this thing, right? Because I was one of these, and we talked about my case of coming into fake networking, where there is a hesitation and a want to just manage every single little component. The thing I would just say is, like, all those components are still there. Don't worry that these things are disappearing. The thing that I would say, though, is like if the industry is moving to this direction of kind of simplified architecture for developers, right? Because that's like, how do I improve that business logic? What I would say is like, as a network admin, get in there and own this, right? Like this should be your object that allows that simplicity that's natively integrated with all those compute engines, but like it still gives you that architecture sense to be able to kind of enforce the connectivity primitives and the security enforcement and have that visibility to help with architecture decisions. Like that is just the kind of new network model. And you can either let the developers run it, or you can take it on and take ownership and do that kind of stuff. And so in my mind, I just think of like, this is something to embrace from a network perspective instead of thinking it like, oh man, like it's going away. But I will say, like, unless you do, it is built so that a developer could take it and run with it, right? So it's like one of those ones where it's like, where do you want it to go? What do you want to do? And so I think I personally am a network person. Of course, I think network people are the perfect people to own this, you know, have the developer own the service creation, the automation around that stuff. But own the service network, own those logs, own the security primitives, enforce authentication. Things like that are like right up an admin route. You know, I love that stuff.
So for me, since I'm the host, I get to have the final words. Ken had asked, can we have a part 2, more deep dive and some scenarios and demos? Absolutely. I'll set it up and I'll invite Matt and Justin back, of course, and we'll run through that because I think that is definitely a thing. My quick closing thoughts on this is that this is the tip of the iceberg, right? There's going to be more of this, more of these things. Justin's got a lot of things going on inside of that head of his, right? So, and other PMs too. It's not just all on Justin's shoulders. We've got a whole bunch of folks in the what we call the EC2 networking org that are working on these things to make things a lot easier and better. But the way that we do that is for you, all of you folks that are watching and asking these questions, to tell us what we need to do to make this better and what you need. So now that you can see the art of the possible of what Lattice can do, help us get to that next step and to that next level and give us that rich feedback that we need.
I'm feeling a demo next time. What do you guys think?
Absolutely. Yeah. Absolutely. We should definitely do a demo. But yeah, so we are 1 minute away. Thank you, Justin, for coming. We're going to have you back for round 2. Matt, as always, good stuff. And we'll see you guys next time.
See you, everybody. Thanks for having me.